Chapter 9. Back data. I'm going to get rid of these two columns. Those. And partition the data to train and valid. Then we ran the default tree using R. Provide the formula target, and we're going to use all the variables, and then for the train data. And method equal to class. The method equal to class is required if the target is not a factor. If the target is a factor, then method will be automatically class. We don't have to specify. So right now, the target is a 0, 1 variable. It is not defined as factor, so we have to specify that. Okay? So if you don't have any control or any other parameters for R, then you're going to have default. The default tree is right here. Okay, and we can control the way in which the decision tree gets printed using the type and then the extra parameter, and we can also control the color of the nodes by specifying either you can specify auto or box.tab, or you can specify a particular color scheme that you want. Okay. Now there are a couple of more, 2 or 3 more tree details that we can extract from the tree. Okay. So a few things that we may want to look at is how many nodes there are. So to specify to count how many nodes there are, we can look at the tree object and then the frame. So the tree object is bank.tree.default. Okay, so let's check it out in terminal first, and then we put it in the regular code area. So now if you select frame and then var or variable, then that will give you all the variables that were used to split in each of the nodes in the tree. Okay. So these are the variables used. Okay. And when it is a leaf node, so that means the leaf node is one where you don't have any further splits. There is no split variable in those nodes. So then you have the name of the variable is given as SD. That means there is no variable. There is no split. So we can use that with length method. Okay, so here we can say length that particular object. So that would be bank.tree.default. Okay, and frame.var. So how many objects are there in that element? So that will give you the total number of nodes. Okay. So if you run that, it tells you it has 15 items in it. So that's your tree size, how many nodes there are. Okay. So now we want how many leaf nodes there are. Then we have to do length. Okay. default. Okay. But now this time, okay, and then of course frame and var. But we want to count only the leaf nodes. Okay. So we have to say inside the square bracket. So you have to look for again math.3.default frame var. Okay. And then the condition is that equal to leaf. Okay. So you use two equal signs because it is a comparison operator. Now it's going to count the length only if the condition inside the square bracket is true. So if the condition inside the square bracket is true, then it is leaf node. So now should be inside the quotation mark. So there are 8 nodes that are leaf nodes. There are totally 15, out of which 8 are leaf nodes. Okay, and then we have there is a. Okay, so now let's say that we want to print 3 rules. How do you classify new cases? Okay, and then we can use using R rules method. So we say R dot rules. And then give the name of the tree. Math.tree.default. And then that will print the rules for you. Okay. So it gives you what is the prediction at the beginning and then the rules here. It's kind of not very nice looking. So we can specify some options. So style, so we have 3 options for style. One is wide, that's your default. So wide is the default. So it's going to give you what we already had. Okay, or you can say tall. So tall would be like this. So it will give you the rule in this fashion. So it's telling you what classification you should predict when certain conditions are true. So it says predict personal.loan as 0 when this rule is true. Okay, and then here is another rule. Predict it as 0 if this is true. And so on. And then here, personal loan, actually the number that you see is the probability. Okay, so the 0 probability that personal loan is 1. So if this is true, then you will classify it as 0 because the 0 probability is 1. So same here, it is 0.27 is the probability. Okay, now if your cutoff is 50%, here is where you start predicting your personal loan to be equal to 1 because the probability is 0.82 or propensity is 0.82 here, 0.98 and 1. Okay. And then there is a third possibility which is tall W. Okay, so it's kind of in between the wide style and the tall style. So it's going to give you like that. Same thing, printed in a different way. Okay. So for 3 details, these are the 3 things that would be of interest to you. How many nodes are there in total? And how many of those are leaf nodes? And then the rules